In this episode of Remote Trigonometry, we will be looking at the other four trig functions. Sine and cosine form the actual wave functions. The other four trig functions are still important, but they don't actually form waves. Tangent is defined to be sine divided by cosine, or the y-coordinate on the unit circle divided by the x-coordinate on the unit circle. So again, here's our unit circle with our graphs of cosine and sine. So when you're graphing tangent, you want to think about what is going on with both sine and cosine so that you can imagine what their ratio is. Notice that we're dividing by the x-coordinate, or we're dividing by cosine. So anywhere that cosine is 0 is a place where tangent has a vertical asymptote. And so at 90 degrees or pi over 2 that's one of the locations. At 270 or at 3 pi over 2, at negative 90 degrees or negative pi over 2. So basically we're picking out the points at the top or the bottom of the unit circle. You're on the y-axis, and so x is 0 at the top and at the bottom of the unit circle. So basically any odd multiple of pi over 2 is a location where tangent has a vertical asymptote, and thus those values are excluded from the domain. The range is all real numbers. You can see the graph of tangent stretching out to negative infinity and positive infinity. There is sort of this center line at 0. It's, again, not quite as significant as the line of equilibrium for the waves, but it does create some symmetry. This part of the curve is symmetric to that part of the curve, but just flipped around. And it's where the inflection point occurs. We're changing concavity at that point. Tangent repeats after only a half circle. So in quadrant 1, sine and cosine, x and y are both positive. In quadrant 2, x is negative and y is positive, so the values of tangent will be negative. But then in quadrant 3, x and y are both negative, and so tangent will be positive. And then quadrant 4 is going to repeat the same negative values for tangent that quadrant 2 did. So the wavelength of tangent is only a half circle, it's pi. And then the frequency per 2 pi would be 2. You get 2 cycles in one trip around the circle. So if you're really starting from 0, you're starting at this inflection point and heading up to infinity on one side of the asymptote, and then the other half of the cycle is over here, and then you're repeating again at pi, so that this point is at pi. You're repeating this same shape over there. So that's how you can kind of see from 0 to pi, you get one cycle and then you just start to repeat. So that's the main important things about tangent. Secant is defined to be the reciprocal of cosine. And so once again, where cosine is 0, you're going to have vertical asymptotes. So at pi over 2, at 3 pi over 2, at negative pi over 2, at negative 3 pi over 2, etc. And cosine goes back and forth between negative and positive 1. And so the graph of secant actually has a minimum point at these maximums and a relative maximum point at the minimum points on cosine. So the graph consists of these U shapes that kind of fit in between the vertical asymptotes. And if you think about it, 0, cosine is 1, so secant would be 1 divided by 1. So you're hitting a minimum value of 1, and then as cosine becomes a fraction less than 1, 1 divided by it gets higher and higher until it's approaching infinity as cosine approaches 0. And then on the other side of that asymptote, cosine's now negative, so we immediately switch from positive values to negative values. And so right on the other side of pi over 2, we're coming up from negative infinity at pi. So this point's at pi. Cosine is equal to -1. And so we're hitting 1 divided by -1, or a relative maximum of -1. And then as cosine again becomes a fraction whose magnitude is less than 1, the value becomes a larger and larger value, although in this case it's still negative, so we'll be heading to negative infinity. So notice we keep repeating these U shapes back and forth. Now, a full cycle contains 1 upward facing U and 1 downward facing U, and cosine's wavelength or period is 2 pi, so secant is going to have the same length of period. It's going to take a full circle to get all the values of secant. If you start at 0, notice you get this half of the upward facing U, then you get a full downward facing U, and then you get the other side of the upward facing U ending at 2 pi. So that's 1 full cycle. Or you could look at a full cycle as an upward facing U and a downward facing U, and then you repeat again. Notice we still point out that the center line is y equals 0, because the U shapes are symmetric about that line. So y equals 0 is kind of in the middle between the upward U's and the bottom U's. And by the way, this distance is 1, and if you like, we're just graphing 1 times secant, and so that distance is 1. Later we'll look at an example where if you had a coefficient here that was not 1, that coefficient is telling you, it's kind of like an amplitude, it's telling you how far the U shapes are from the line of equilibrium. Now cosecant is sine's reciprocal. I know it kind of seems like those two are reversed, but cosecant is sine's reciprocal. So where sine is 0, you're going to have vertical asymptotes, and that will be at any multiple of pi. So n times pi are where the vertical asymptotes are. So 0 times pi, 1 times pi, 2 times pi, -1 times pi. Those are all the values where we are hitting vertical asymptotes. And also those are the values that get eliminated from the domain. So notice my domain is x cannot be any multiple of pi. X can be anything else but a multiple of pi. The range is like the range for secant. So I know I didn't talk through it with secant, but it's the same for secant and cosecant. You're coming up from negative infinity and stopping at the tops of these downward facing U shapes. So we're going from negative infinity to -1, and then we turn back around again. Then we switch on the other side of the asymptote, and we come down from positive infinity to 1, and then turn back around again. So the range for both secant and cosecant is from negative infinity to -1, and that's one set. And then you combine with it or union with it from 1 to infinity. Notice the -1 and the 1 are included. We actually hit those values. It's not really possible to hit infinity, so we use a strict inequality there. Again, 0 is kind of our center line. The graph's kind of symmetric around that. And then it takes a full circle, 2 pi, to repeat. And thus you have a frequency of 1 per 2 pi. So that's the gist of secant and cosecant. Cotangent is the reciprocal of tangent. And so it also could be rewritten as cosine in the numerator and sine in the denominator. So where sine is 0, that's where our vertical asymptotes would be. So we just got done talking about cosecant, where sine was in the denominator. So at any multiple of pi, we're going to have a asymptote. So at 1 pi, at 2 pi, at negative pi, at negative 2 pi, etc. And then those are the values that are excluded from the domain. So the domain is x cannot be any multiple of pi because it'll make sine 0 and dividing by 0 is undefined. But like tangent, the range is all real numbers. You can see the graph going from negative infinity up to positive infinity. There's kind of no break in it. And we have that inflection point line, that kind of center line at y equals 0. Just like with tangent, cotangent is the reciprocal, so it'll repeat after a half circle. So the wavelength is pi. And then you get 2 cycles per trip around the unit circle because it only takes a half circle to complete a cycle. So one of these cycles occurs between 0 and pi, and then you get another repeat of that same cycle. Like with any graph, you can do transformations to the graph. And so here we have an example of 8 times tangent of 0.5 times x, and then we've added 5. So the principles of graph transformations hasn't changed. That plus 5 shifts the graph up 5. So notice my inflection points are now at 5. They're not at 0 anymore. And the 8 is making the graph very steep. That's why you almost don't notice the inflection point, because the graph is so steep it's almost turning into a straight line, but it's slightly curved with an inflection point on the line y equals 5. And so the 0.5 is slowing the cycle down. It's now going to actually take 2 pi to complete a cycle, because the 0.5 multiplying the x is slowing the cycle down. If you actually remember that tangent has you dividing by cosine, what's inside of the tangent, it cannot equal an odd multiple of pi over 2. But I have 0.5 times x not equaling an odd multiple of pi over 2. So if I solve that for x, I want to multiply by 2 to cancel multiplying by 0.5. And so if I multiply both sides of this by 2, I will get x not equal to odd multiples of pi, because the 2 in the denominator divides out the 2 in the numerator. So that's now my domain. My domain is x cannot be odd multiples of pi. And so every other pi is going to create an asymptote, and hence you'll get a full cycle every 2 pi. So my asymptotes are at negative pi, at 1 pi, at 3 pi. Okay, that's where the asymptotes are. So between pi and 3 pi, that's a distance of 2 pi. So you could see that the period is 2 pi. I'm getting 1 cycle per 2 pi, and again the 8 is making it very steep. Here's an example where we've done some shifting with cosecant. A lot of the things we say about this would apply if it had been secant. There's not a whole lot of difference between secant and cosecant. They're just the same graph shifted from one another horizontally. So in this sense, the 6 shifted the graph up. So notice that center line in between the U shapes is at 6 now instead of 0. The 0.75 is actually making it less steep, but also that's how far the bottom and the top of the U shapes are from 6. So this y value is 6.75 and this y value is 5.25 because that distance is 0.75 due to the coefficient here. Pi times x, pi is now the frequency, so I'm getting pi, or a little bit more than 3 cycles per 2 pi, and so the period is now 2 pi divided by pi, or 2. So from 0 to 2, I get 1 cycle. You could see that here, an upward U and a downward U from 0 to 2. And then an upward U and a downward U from 2 to 4. And then an upward U and a downward U from 4 to 6, etc. So you could see that the period, or the wavelength, is 2, and the frequency per 2 pi is pi. I would actually complete 3.14 approximately cycles if I looked from 0 to 2 pi. And that's everything important about that graph. Oops, I left off something that is important. The pi times x is creating a domain that x cannot be any integer. The reason why that is because pi times x cannot be any multiple of pi, because cosecant is 1 divided by sine. Sine is 0 at any multiple of pi. So that means that x cannot be any integer. So we can see that's where our asymptotes are. I have an asymptote at 1, I have an asymptote at 2, I have an asymptote at 3, I have an asymptote at 4, I have an asymptote at 5, etc. So anyway, my domain is x cannot be any integer, and when you look at the graph, that's where you're seeing the asymptotes. Now we've talked about everything important in the graph.